What is up, geometry students? We are going to review for our big quiz, starting with question 1A. What is the length of the line segment AB? Well, we have talked about how lengths of line segments can be found using the Pythagorean theorem. But that's only when we have a diagonal length. If you look at AB, whether you plot it out or just think about it, A being at negative 2, 5, and B being at negative 2, negative 7 means these points are stacked on top of each other vertically. You can see there's no x change, there's just a y change. Well, if there's no x change and just a y change, well, then that's going to be your length. It's going to be this vertical length of 12. Now, we're not going to say that the length is negative 12. We don't say we go 5 to negative 7 and the length is negative 12. We say the length is 12. And that's the same thing with D, with question 1B, which we're talking about points C and D. D is at 3, 3. C is at 8, 3. Well, these points are located horizontally from one another. 3, 3, then 8, 3 are 5 away from each other. You can see you have a x change of 5 and a y change of 0. So we just say, since there is just an x change, we use 5. Whenever things go diagonal, Pythagorean theorem is there to help. So, understanding, and now we are in the diagonal world, you can see what we're doing here is just going through one lesson at a time. In the diagonal world, when we go from negative 1, 5 to 3, negative 1, that we have a horizontal displacement and a vertical displacement. And x goes from negative 1 to 3. That would be a horizontal distance of 4. A y's going from 5 to negative 1 would be a vertical distance of 6. We'd say the vertical change is minus 6, but I'd say the distance is positive 6. If I were to find the slope, I'd say it's negative 6 over 4. Now, this is fine. We can leave this. However, it might be easier to use a simplified negative 3 over 2 slope. But if we were to ever create a new line segment with the same length as this line segment DG, we would need to keep that negative 6 and keep that 4 and not change it to 3 and 2. What is the equation of the line that passes through both points D and G? Well, it's all the points that, using the slope of negative 3 halves, work with either this point D, negative 1, 5, or this point G, 3, negative 1. Pick whichever point you want to use, it doesn't matter. I'm going to pick 3, negative 1. And we use the equation y minus y1 equals m times x minus x1, which is just a variation of the slope formula, where we know what m is. We don't know what x and y are. We want to find the collection of all xy's. And when we do x minus x1, we are finding the change in x, and y minus y1 is the change in y. Make sure if you're subtracting negative 1, you turn that into plus a 1. So I got y plus 1 equals negative 3 halves x minus 6. What is the equation of the perpendicular bisector to line segment DG? Well, perpendicular bisector means we need to find the midpoint. The midpoint is the point in between negative 1, 5 and 3, negative 1. All we have to do is just go halfway, kind of make a pit stop from negative 1 to 3. I'm going to add 2 from negative 1 to get to 1. And 1 is smack dab in between negative 1 and 3. We can also find the average of these two values. And then from 5 to negative 1, instead of subtracting 6, I'll subtract 3 to get to 2. So 1, 2 is the midpoint. So I'm going to write our point, 1, 2. Then I'm going to realize that our slope of our perpendicular line must be positive 2 over 3, or positive 4 over 6. Remember, negatives over negatives are positives, so don't change this to a negative over a negative, because it's actually the same as a positive over a positive. And then we have y minus 2 equals 2/3 x minus 1. Question 3, line segment PA is parallel to line segment RL. RL is 1, 2, 3, 4. So 1, 2, L is 3, 4, 3. Cool. So R is 1, 2, L is 4, 3. PA is parallel to. Cool. Cool. It doesn't say it's like the same length, but I'm going to make sure it's the same length. So RL has a slope of 1 over 3, y's over x's. P is located at -3, -2. What's a possible location of A? Well, if we're parallel, that means the slopes are going to be the same. So the change I have from R to L will be the change that I want from P to A, which means I'm going to use a y change of +1 and an x change of +3, giving us to a point A that is possibly at 0, -1. Could also go in the opposite direction if I wanted to, and instead of adding 1, subtract 1, and subtract 3 to get to -6, -3. But 0, -1 is totally fine for a possible location of point A. Line segment RG is perpendicular to line segment HT. Okay, great. RG is perpendicular to HT. H is 0, 3. T is 1, -2. Cool. So HT has a slope of -5 over +1. So the slope of HT is -5 over 1, which means the slope of RG has to be +1 over 5. This +1 refers to the y change. This +5 refers to the x change. If R is located at 1, 2, I will apply my y change and my x change to get G's location, which is 6, 3. That's a possible location of G. We could also go in the other direction if we wanted to. But the equation of the line of all possible xy's points that have a slope of 3 and passes through the point 1, -2. Okay, well, y minus y1 equals our slope times x minus x1. This will be all of our possible xy's that when connected to 1, -2 have a slope of 3. So we're good there. And 6, a line has the point -1, 3 and has a slope of 2. Find the missing y coordinate of point 4y. Well, here we can start with the equation of all the possible xy's. And this is a great start. This is us kind of using our slope formula to help us find the missing point. 4, comma y. We'll plug in 4 for x and we will find the y. Don't have to distribute. You can just do 2 times 5. 2 times 5 is 10. And then add 3 and I get that the y coordinate is 13. So 4, comma 13. Line has a slope of 3/4, passes through the point 1, 4. What is the equation of the line? Y minus 4 equals 3/4 x minus 1. What is the coordinates of the x-intercept? That's when y is equal to 0. I will need to solve this equation. -4 equals 3/4 x minus 1. I could distribute, but I think the easiest way to solve this is to multiply both sides by 4. Because of this parentheses, I'm not distributing the 4 everywhere. I'm just going to multiply the 4 by the 3/4, and I get -16 equals 3 times x minus 1. Now I'm going to distribute. You could also do this different ways, but it would be tougher if you were using fractions, if you distributed the 3/4. Distributed the 3/4, you'd have 3/4 x minus 3/4, and you'd have -4 equals 3/4 x minus 3/4. I'd add 3/4, and then I'd have to multiply by 4/3. Here, kind of multiplying by the 4 first to the 3/4 x minus 1. I get -16 equals 3 times x minus 1. I distribute the 3. I add the 3. So I get -13 equals 3x, and I divide by 3 to get x equals -13/3. And if we are using this equation, and we are finding the y-intercept is when x equals 0. So we have x comma 0 for our x-intercept, so negative 13, 3, 0. Y-intercept is going to be 0 comma y. So I have y minus 4 equals 3/4, 0 minus 1. I will then add 3/4 and 4 together to find y. 4 is 16/4. 16/4 plus 3/4 is 13/4. So I have 0 comma 13/4. Okay. Question number 8, line H has a slope of negative 3, passes the point through the point 2, 6. So I have y minus 6 equals negative 3, x minus 2 is the equation of H. Line D is perpendicular to H and passes through the y-intercept of H. So I have to find the y-intercept of H. The y-intercept of H is when x is 0. So I get y minus 6 equals 6 after plugging in 0 for x. I will add 6 to get y equals 12. Cool. Line D is perpendicular to line H, so line D will have a slope of positive 1/3. Line D will have the point 0, 12. So I have y minus 12 equals 1/3 x minus 0. Cool, midpoint. 2, 4, 6, negative 2. A is 2, 4, B is 6, negative 2. From 2 to 6, I'm adding 4. From 4 to negative 2, I'm subtracting 6. The midpoint will be halfway in between. So instead of 2 plus 4, I'm going to do 2 plus 2 to get a x coordinate of 4. Instead of 4 minus 6 to get to negative 2, I'll go halfway and subtract 3, and I'll have the point 4, 1. You can also take the average of your points and get the answers that way. Perpendicular bisector of CD. Okay, so CD, C is negative 8, 9, D is negative 4, 1. So perpendicular bisector passes through the midpoint. I need the midpoint to bisect. So from negative 8 to negative 4, I'm adding 4. So let's go halfway by adding 2 to negative 8. 9 to 1 is subtracting 8. Let's go halfway by subtracting 4. And 9 minus 4 is 5, giving us the points negative 6, 5. Cool. We also know that the slope of CD is negative 8 over 4, which is negative 2, which means my perpendicular slope will have to be positive 1 over 2, or positive 4 over positive 8, giving us the equation y minus 5 equals positive 1/2 x plus 6. I'm going through the midpoint, and I'm using a perpendicular slope. Okay, we want the location of the y-intercept of the perpendicular bisector to the line segment. So we're going 0, 6. We're going 4, 6. I will go halfway by adding 3 to 0. I'll go halfway by adding 1 to 4. I have the point 3, 5. I see the slope of EF is going to be 2 over 6, which can be simplified to 1/3, which means our perpendicular bisector will have a slope that's negative 3. I have the point 3, 5. So y minus 5 equals negative 3, x minus 3 is the location of all xy points that work with the point 3, 5 that have a slope negative 3. And I'm finding the y-intercept, which is when x is 0. So I got y minus 5 equals negative 3 times 0 minus 3. I have y minus 5 equals 9. I will add 5 and I get y equals 14. So 0 comma 14. Great. When we simplify the square roots, we try to understand that some square roots are, I like to write them out, like Some square roots simplify to be just easy numbers. The square root of 9 is 3 because 3 times 3 is 9. Some square roots we cannot simplify because it doesn't work out to be a nice number at all. Like, what number times itself equals 10? I don't know. That's the same for the square root of 11. Square root of 10, I'm leaving as the square root of 10. I don't know what that's equal to. Square root of 11, I can't. However, some square roots we could rewrite to kind of pull out the nice, easy numbers that exist in it, or to write what's called a simplest radical form. What I do is I try to find the greatest perfect square, like 4, 9, 16. Remember, 4, 9, 16, 25, 36. You should be able to produce these numbers yourself. The square root of 4 is 2 because 2 squared is 4. The square root of 9 is 3 because 3 squared is 9. We say, oh, root 12 is root 4 perfect square times root 3. The square root of 4 is the nice number 2. The square root of 3 is not a nice number. It's just the square root of 3. That's the idea, team. The idea is we need to, when given the square root of 16, no, it's 4. When we're given the square root of 10, no, we can't do anything. But when we're giving any other number, attempt to take our biggest perfect square, see if it fits in. I know 4 goes into 60. You can use your calculator to help. 60 divided by 4 is 15. I know that 4 times 15 is 60. So root 4 root 15 is root 60. Root 15 does not have 4 or 9 or 16 or 25 in it, so this cannot be simplified, but the square root of 4 is 2. 2 root 15 is the simplified root 60. 50 is 25 times 2. So root 25 times root 2 is root 50. The square root of 2 cannot be simplified, but the square root of 25 is just 5. Cool? The square root of 16 is just 4. The square root of 10, we would say, is just the square root of 10. We can't simplify it. So remember this, square roots, sometimes they're nice, sometimes not as nice. Cool. Moving on into the next, find the lengths of line segments. Well, we realize that line segments can have a horizontal component and a vertical component. Our slope, thought of as separate values, our y change, our x change, combined using the Pythagorean theorem can give us a diagonal distance change. The length of a diagonal is like the length of a hypotenuse of a right triangle. We use a squared plus b squared equals c squared. So a squared plus b squared equals c squared. This is a side length of a right triangle, the plus 2 from a to b. This plus 1 is a side length of a right triangle. So a squared plus b squared is 5. C's square is 5, which means c must be the square root of 5. We try to simplify that. If we can, great. If we can't, we leave it. The line segment shown for number 14 is 1, 1 to 3, negative 5. So that means 1 to 3 is an x change of 2. 1 to negative 5 is a y change of minus 6. A squared is 36 plus b squared is 4 equals c squared. 40 equals c squared, which means c equals the square root of 40. Try to simplify this. What perfect square goes into 40? 4 root 10 is root 40. 2 root 10 is root 40. Find the x-intercept of the perpendicular bisector of the line segment shown above. Great. Well, instead of subtracting 6, I'll subtract 3 to get to a y-coordinate of negative 2. Instead of adding 2, I'll add 1 to get an x-coordinate of 2. The slope of this line segment is minus 6 over 2, which is negative 3. which means the slope of my perpendicular bisector will be positive 1/3. So I have y plus 2 equals positive 1/3 x minus 2. The x-intercept is when y is 0. Plug in 0 for y. I'm going to multiply everything by 3 to get rid of the 1/3. When I do that, I get 6 equals x minus 2, because the 3 and the 1/3 will cancel each other out, and I get x equals 8. Find the distance between the 2 points. Well, distance is the same as length. If you have 10, 2, and 7, 0, the distance between these 2 points is just the length. All we use is the Pythagorean theorem. 10 to 7 is a minus 3. 2 to 0 is a minus 2. This is an A, this is a B. Does it matter that it's negatives and positives? No. Negative 2 squared plus negative 3 squared equals c squared. 4 plus 9 equals c squared. C squared equals 13. C equals root 13. Oh, but heads up, what if I give you the longest side length? The longest side length is opposite the biggest angle. If I give you the longest side length, oh, we might have to find an A or B. So for question 16, the longest length is 6. Looks like the middle length is 5. I would have to do A squared or x squared plus 5 squared equals 6 squared. I realize A squared equals 11, which means A equals root 11. Pay attention to the 90-degree angle. The hypotenuse will always be opposite the 90-degree angle. One of the legs of a right triangle is twice the size of another leg. So if this is twice that, I say one is x, the other one is 2x. I say A is x, B is 2x, the hypotenuse is 6. We use the Pythagorean theorem, but A squared plus 2a squared, or 2x squared, 2x times 2x is 4x squared equals c squared. This one is tricky. I screwed up on this. I think I changed this to 10 on the actual quiz, but let's just go with it. What happens if you have 36 divided by 5? Well, you have 36 divided by 5. What happens if you have to square root that? Well, you have the square root of 36 divided by 5. It is a number. Doesn't work out nicely, but still correct. The hypotenuse is 3 times the size of a leg. So I got that one of the legs, call it A or B. The hypotenuse would be 3a, and the other leg is 4. You can use x instead, x, 3x. You can use b, 4b, 3b. Your call. Pythagorean theorem, a squared plus b squared equals c squared. I get some version of 16 plus a squared equals 9a squared. I subtract a squared from both sides. I get 8a squared. I divide by 8. I get 2 equals a squared. I will square root to get a is root 2. If a is root 2, 3a is 3 times root 2. Do not say this is root 6. 3 times root 2 is root 18. But root 18 can be simplified to be 3 root 2. So we leave it as 3 root 2. What are the 2x coordinates to the point x3 that are 6 units away from the origin? Ooh. If I'm going from 0, 0 to x3 and I have 6 units away, I'm telling you the length of a diagonal. I have the b length, but I don't know the x length. So x squared plus 3 squared equals c squared. X squared has to equal 25. X could equal plus or minus 5. Ooh, wait. 36 minus 9. That can't be right. 27. So x squared has to equal 27. X has to equal the square root of 27. X has to equal root 9 root 3, which is 3 root 3. However, we could have added or subtracted 3 root 3 to 0, and this would have worked. This is not going to be on your quiz.
Like a band of pirates walking around the school.
I know, it's just like everybody, just spend the rest of the day in the spirit room,
Getting
you know?
food.
Everybody. Not up in here, though, right?
No.
You step in the math office, you're stuck for life. 20 is going to be on the quiz. 21 not on the quiz. So 19 and 21 not on the quiz. But 20 is. 4 easiest points that are 5 units away from the point 1, 2. Up 5, down 5, left 5, right 5. Adding 5, subtracting 5 from the x and the y coordinates. So 6, 2 would be 5 to the right of 1, 2. Negative 4, 2 would be 5 from the left of 1, 2. 1, 7 would be 5 up from 1, 2. And 1, negative 3 would be 5 down from 1, 2. And if you were to do question number 21, you'd say you got 0.32, you got the 0.7y. We have 5 units away. That's our C value. We have the idea of like 3, 2 to 7y. This length is 5. I'm giving you the C. The x changes plus 4, but the y change is y minus 2. Now, what we need to know is that we can keep the y minus 2 change and just call it a b. And 4 squared plus b squared equals 5 squared. We realize b has to be 3. We have a 3, 4, 5 right triangle. If b has to be 3, that means I should be adding and subtracting 3 from 2. So I would get y coordinates of 5 and y coordinate of negative 1. Now I'll let you know this is something we actually don't think we're going to put on, we are not going to put on the quiz. This was like the most advanced type of problem, and we can understand how it's very confusing to students. But the idea is I'm giving you C, and I'm giving you either like an A or a B. And you're finding the other leg's length, and you're applying it to a point, is really the idea behind this. And what it's leading us to understand is what we're doing after the break, which is all of our points given a distance away from a center is an equation of a circle. And we will see that we will be using the Pythagorean theorem to produce the equation of a circle, which is cool. Peace.